Hi everyone, today I will be beginning with the first chapter of ICSE syllabus, which is periodic table. In class 9 already you have come across the concept of periodic table, that is groups of elements which show similar properties obviously we need to be clubbed together. Okay, so scientists came up with different ways or proposals to group these elements together. So now let us come across every time zones how the elements were classified. Earlier chemists used the method of classifying the elements on the basis of valency, metallic character, and non-metallic character. Okay, suppose if you have elements, if two elements A and B have valency 3, 3. So these two elements were clubbed together in same group. Now if you have A, B, C, valency 3, 2, 1, they all will be in different groups because the valency differ. But this method was not acceptable because, or rather I would say it was discarded later on, because suppose you take an example of iron. You know what is the valency of iron? It exhibits +2 as well as +3. So because of this dual valency character, this method was not acceptable. That is, elements which shows dual character were same element having dual character were placed in different groups, which was not acceptable. So in 1815, Daubigny came with a new concept of arranging the elements, classifying the elements. What he did was he arranged elements in the increasing order of atomic weights. Okay? But he grouped three elements A, B, C. Suppose I'm taking an example in terms of A, B, C only. In a group called triads, where the middle element will always have an average mass of mass of A plus mass of C by 2. But this way of classifying did not hold true for all the elements. So this method was also discarded. Newland also continued the proposal proposed by Daubigny only. He also arranged elements in the increasing order of atomic weights. Okay, but instead of taking 3 elements together, he took 8 elements together, known as octaves, where the first and the 8th element shows resemblance in the properties. Okay, but what was the problem with this method? It did not leave space for undiscovered elements. So this method was also not acceptable. Let me clear off the screen for you all. So the next scientist which proposed way of classifying the element was Mendeleev in 1869. He also carried forward the same idea of arranging the elements in the increasing order of the atomic weight and put elements in the tabular form. Okay, but this method also had some problems. That is, it did not leave space for the undiscovered rare elements or could not justify the position of the rare elements isotopes. As you all know, elements shows the property of, just a sec, isotopic, where you have same atomic number, same, but mass number not same. So suppose take an example of chlorine itself. It has 35 17 1 and chlorine 37 17. The same element which shows isotopic character will be placed at different groups, which is also not possible. So in 1912, Moseley came up with the modern periodic table. He also did the same thing what Mendeleev did. But the difference what he did was, instead of increasing elements and increasing order of atomic weight, he arranged in increasing order of atomic number. Clear? This is a very important concept. The whole periodic table will be based on this concept, the property of atomic number. So, after classifying the elements in the increasing order of atomic number, the modern periodic law states an element always have a physical plus chemical property, and these properties will be the periodic function of atomic number. ठीक है? Why periodic? That means after a certain interval of time, the same property will repeat itself, which will have been influenced on the atomic number. ठीक है? So what he did, arrange element in periodic tabular form. Done. Now let us discuss some salient feature. The first feature that we will come across about the periodic table is that it is based on the fundamental property of atomic number. This atomic number helps in correlating the position of the element with its electronic configuration. Now what is the funda about this atomic electronic configuration atomic number? You all know element in neutral state have same proton and same number of neutron, and number of protons is always equals to the atomic number. So indirectly we can say atomic number is equals to number of electrons. Okay, now these electrons will arrange itself in the orbital shells you have read in class 8-9. So therefore the arrangement of this electron around an atom in different shells is called electronic configuration. So the position of the element will be correlated with this electronic configuration. If you know the electronic configuration of an element, you can always state where it is placed in the periodic table. Okay? Third feature that you come across is elements will be arranged in rows and columns. The rows are called period and columns are called groups. Okay? Now the clear? Now change as you move from group A, group B, group C, group D, there will be a gradual change in the atomic property of the element. Okay, either it will decrease, increase, remain same. So that's all. Okay, so there will be some change, but it will occur gradually. And let's discuss more deeply about periods and groups, because questions do come here. Okay, the one thing which I forgot to mention, was, suppose if I have in your question, because in section A you come across MCQ, okay, and you will be given physical and chemical property of an element increase in the order of arrange in the increasing order of atomic volume, atomic size, atomic weight, atomic number. So you need to know the periodic law. Okay, if you do not know the statement, you might miss out the options here, because it might look same, because you might have read the atomic, something was there in atomic, you would have clicked in any one of the options. Okay, this was the thing which I need to mention. So be careful while you are reading the laws. Each and every term in the law will or rather I would say it's very important. Once a term you have missed out will cause problem for you while answering the question. Very simple question would be asked and you might missed it out. Okay. Okay. Now let's come. What I said earlier, that elements were grouped, arranged in period and column groups. Suppose this is a table. This will this are called rows and this will be called period. So it will go from period 1, 2, 3, 4 and so on. Okay. So what does this period signify? Why it is so important to us? Okay. The period number is always equal to the number of shells. Suppose I say an element X is in period 6. It means that number of shells is 6. Suppose this is an atom, this is the nucleus of an atom. These are called the shells. So there would be such 6 shells. Okay. One thing you need to remember, in a period, that is from left to right, as you go, number of shells will never change. It will remain the same for that particular period. What I'm trying to say is, for period 1, as you go from left to right, the number of shells will always remain 1. Okay. But what does it change as you go from left to right? The valence electron will increase from 1. Okay. As the number of electrons are increasing, so does the non-metallic character will increase. Non-metallic character indicates the number of electrons, excess electrons it has. A metal will always be deficient of electron and non-metal will always be excess of electron. So if an element is non-metallic, that means it has more electrons than protons. So if you are increasing electrons by 1, so the metallic character will also increase. Remember, things to remember for a short question is that there are 7 periods, period 1, 2, 3, 4, 5, 6, 7, but period 1 is the shortest, which has only 2 elements. that is hydrogen and helium. Okay, you need to remember from the periodic table elements from 1 to 20. The names of the elements with its atomic number. It's very important because you need to write down the electronic configuration, and from the basis of electronic configuration you need to answer the questions that has been asked. So you need to remember this, and this short question might come, which is the shortest period and or how many elements are there in the shortest period of the periodic table. Okay? Now we'll see a term called bridge elements. You have seen a bridge. Suppose a road 1 and road 2 is there. In between there is water and you need to cross the road. So how would you do that? The engineers will make a bridge for you and will cross it. Okay, this is the concept of bridge. Similarly, we see that period 2 and period 3 elements have resemblance in the property. That is, the elements of the period 2, suppose I am taking lithium, shows resemblance in the property with magnesium of period 3. That is, they are diagonal in nature, and this resemblance in property is shown by period 2 element with the next element of period 3. Okay, and these elements are called bridge elements. I have written typical element because in period 3 you will always have these elements: sodium, magnesium, aluminum, silicon. But if magnesium shows resemblance with lithium, they have a bridge relationship between them. Okay, short question might come, or just for your basic knowledge I have taught this chapter. No, topic, sorry. We have done with period. Now let's come with group. In modern periodic table, you will see there are 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Group 1 and 2 are very reactive. Okay, so what in previous slide only I have talked about that, as I've said, the valence electron increases by 1. So this is the valence electron. The group's number signifies the valence electron. For period 1, 3. As if we move from 1 to 18 element, we see the valence electron increases by 1. Each valence electron will signify the group number. Suppose if I say an element has a group 5, that means it will have a valence of 5 electrons. Okay. So what are the properties of the group? In a group, the valence electron will never change. As the valence electrons are not changing, so the electronic configuration would also not change. As the electronic configuration are not changing, its chemical property or physical property will also not change because they are dependent on the chemical electronic configuration. Okay? But as you move down the group, there will always be increasing the number of shells by 1. Okay? Now each groups have a typical name for it. Suppose group 1s are called alkali metals. Group 1 and group 2 are very reactive. Group 2 are called alkaline earth metals. From 3 to 12, they would be called transition metals. That means they are undergoing a transition from a metallic character to a non-metallic character. Group 13s are metalloids, which possess characters of metals as well as a non-metal. Transition metals are always colored. Remember this thing. You might be requiring in your practical classes. Okay. Group 16, group 17 are called halogen groups. And group 18 are called noble gases or inert. Why noble or inert? First thing about inert is that the electronic configuration is completely filled. That means all the orbitals are completely filled. There is no deficiency of electrons, and thus this makes them non-reactive. As they are non-reactive, so they are called inert. Okay? So now I'm asking a question. I'm giving a simple question. Element X has or belongs to period 3 and group 4. Okay. What will be number of shells it has and number of valence electron? It is very simple. Number of shells means it is signified by period number. So number of shells would be 3 and valence electron is determined from group. So it will be 4 valence electron. Reverse question might be asked to you if this number of shells and valence electrons are given and you need to justify the position of the element you have been given. Okay? Okay. The main concept of periodic table is the periodicity. Periodicity is a phenomena which is seen in elements, the properties of elements, rather I would say, not an element, is suppose A, B, C, D, E are elements. 5 elements have taken. What we see that element A and element E have similar properties. So I would say after a certain interval, the properties of an element is getting repeated when elements were arranged in increasing order of atomic number. Okay, this phenomena is called periodicity. So I would say the property which appears at a regular interval in a periodic table are called periodic properties, and the phenomenon is called periodicity. So what is the reason of this periodicity? I have already discussed earlier also. So basically, after a regular interval of time or interval, you will see the valence electronic configuration gets repeated. Okay, suppose I would say lithium has electronic configuration 2, 1. Sodium has 2, 8, 3. It has atomic number 11. Lithium has 3. Okay, 2, 1. Sorry. So you see, for lithium, the valence electron is 1. For sodium, it is also 1. So after certain interval, after 10 elements gap, 8 element gap, sorry, you would see the valence electrons or electronic configuration gets repeated. As the valence electronic configuration gets repeated, your chemical property will also get repeated, because the properties of an element will always be dependent on the number of electrons it has and how are these electrons arranged. These two factors determines the property of an element. So if this property, if the elements, the numbers of electrons and arrangement repeats, the property will also repeat. Okay, so this is the cause of periodicity. Okay, and what are the 5 properties that we are going to discuss in this course would be, first would be atomic radii, the ionization potential, electronic affinity, electron negativity, non-metallic and metallic characters. These are the 5 periodic properties we will be discussing in the next lecture. Thank you. Hope you all like this video. Please do subscribe and like the channel. Thank you.